Hello everyone. Last lecture we started lens. There are two types of lens: convex lens. This is also called as the converging lens. And another one is concave lens. You can call this diverging lens. Okay, so let us talk a little bit more about the convex lens. The convex lens, it has two surfaces. It is something like this. This is one spherical surface and another spherical surface. You combine them. So this spherical surface, it has a center right here. Okay, and this spherical surface, it has a center right there. Now if you erase this and if you erase this and right there, this is the center of the lens. Now if you join this is radius of curvature of this surface. Radius of curvature, you can call surface 1, and if you join this is the radius of curvature of the another surface, this surface. So from, if you call this is the center of the lens, whatever name you can give, like a C or whatever. I think it is better to give, you can give C, not a problem, C. And this is the let me write down whatever you write down, like a X, it is Y, whatever you give, XC, this is R2, YC, this is R1. And if it is a biconvex lens, R1 and R2, they are equal if it is biconvex lens. And this is called as the R1, R2, they are radii, plural, radii of curvature. And this point C, this is the center of the lens, okay. So the line joining, and this is the center of curvature, this is center of curvature also, okay. So the line passing through the center of the lens, this is the center. The line passing through the center of the lens and perpendicular to both surfaces, it is perpendicular right here and right here also, this is perpendicular. The line passing through the center of the lens and perpendicular to both surfaces, right here and right there. This line is a tangent line. So line passing through the center of the lens and perpendicular to both surfaces, that line is called as the principal axis, or simply you can call axis also. So this is the principal axis of the lens. So here you can draw another line also, like simply center line. You can draw this line, you can call center line. Sometimes this is useful, center line, okay. So please know the principal axis is passing through the center of the lens, but it must be perpendicular to both surfaces here and there, then that is called as the principal axis. Same thing applies in case of concave lens also, okay. Now let us draw the convex lens again. This is the convex lens and this is, you can call center line, okay. And I want to draw the principal axis, draw the straight line, okay. And this is the principal axis, this is the center of the This is the center of the lens. So this line is a principal axis because this is perpendicular here and there. Okay, and if you take the rays like this is a ray of light parallel to the principal axis. These two rays, they are parallel to the principal axis and they are coming from the object at infinity. Now what happened here and what happened there? Lens is the transparent medium. So the refraction of light takes place here and there. So light bends. So what happened? It goes like this. And it goes like this right here. They meet at this point. Look, both rays, the incoming rays, or we call incident rays, after passing through the convex lens, they meet at this point. They meet at this point. And this point is called as the focal point right here. This is called as the focal point. Focal point. Okay, this, let me call, this is C, this is F, or yeah, CF. C is the center of the mirror, F is the focal point. So what is focal point? The rays coming from the object, okay, after refraction, after passing through the convex lens, they focus at a point, they converge at a point, and this point is called as the focal point. And this CF, this is called as the focal length F. This is called as the focal length F. So CF is the focal length and F is the focal point. Okay, so CF here, this is little f and this is simply focal length. Focal length. Okay, so there is another focal point here on this side. So if the light is coming from this side, then the rays they converge right there. So this is another focal point you can call F prime. So on both sides of the lens, because the lens has two surfaces, this surface and this surface. So you have a two focal length. So this is also F equal. This is also F. So this point is also the focal point. This is also the focal point. So on either side of the focal length, convex lens, you have a focal point, you have a focal length. And if you want, you can draw the like a center of curvature here, and you can draw the center of curvature there. Okay, so you can call this is, this length is radius of curvature. This length is radius of curvature. You can call R1, and another one is this length. This is also radius of curvature. You can call this is R2. Therefore, R1 and R2, they are radii of curvature, plural form. Singular, you can call radius of curvature. R2 is the radius of curvature. R1 is also the radius of curvature. Together, you can say R1 and R2, they are radii of curvature. Okay, and here you have a focal length F, and here you have a focal length F. So this point, this is center of curvature. This is also center of curvature. You have a two center of curvatures here because you have a two surface, this surface and this surface. Okay, so look at this. The rays after refraction, after passing through the convex mirror, they converge at the focal point. That is why this lens is also called as the converging lens. Okay, another lens we call diverging lens. What happened is, you can draw the diverging lens like this. I told you that the diverging lens is thin in the middle. This is thin. Convex lens, converging lens, that lens is thick in the middle. So this is your diverging lens, or we can call concave lens. This is a concave lens, thin in the middle and thick at the edge here. So you can draw the principal axis. This is your principal axis. And what happened here in this case is, let us suppose this is the ray of light coming from the object, and object is really far. We can say at infinity. Object is at infinity. Now what happened here then? What happened here is, of course, the light passed through this lens. But in this case, what happened is light the ray of light, it goes like this, and it goes like this. This is refracted ray, this is also refracted ray. Look, after passing through the lens, two rays, they diverge. Even if you take like thousands of rays, they diverge. And your image is right here. You produce the image by extending this ray and this ray, but this line, this ray is a dash. This is not the real ray, this is a dash line, the virtual rays. So you have an image right here, and this image is virtual image, and this point we call the focal point. And of course, this length is focal length. This length is focal length. So after passing through the concave lens, the rays of light, they diverge. That is why this lens is called as the diverging lens. And here you have the focal length. This is your focal length, and you have another focal point here also. You can give the name F prime. This is another focal point, and of course this length is also the focal length. And this is the concave lens, or you can call this is diverging lens. The focal length of the diverging lens, we simply take negative number, diverging lens, and the focal length of the converging lens, we simply take the positive number. That is sign convention. We'll talk about it. Okay. So this is the diverging lens. Now, look at this. Let me talk a little bit more about the convex lens again. So this is the center line. You can draw like this. You can draw like this. And this is your principal axis. This is the principal axis. Okay, and this is the center of the lens. Here you have a focal point, you can call F, and you have another focal point, you have F prime. Now if you keep the object there, let us suppose this is O prime object. You keep the object right here. How do you draw the ray diagram? Ray diagram is also important here. So to draw the ray diagram, you can draw one ray from here parallel to the principal axis like this. The ray which is parallel to the principal axis, after passing through the lens, it goes from the focal point. It goes from the focal point. After passing through the lens, the ray parallel to the principal axis, after passing through the lens, it passes through the focal point. So one ray. So how do you take the another ray then? Another ray you can take from this center of the lens. Any ray passing through the center of the lens, that ray does not bend. It goes in a straight line like this. You can use a ruler, okay? It goes something like this. A straight line, okay? You have to make a straight line, but don't make a dash line. You have to make a solid line. Like this. So this ray is passing through the center of the lens, so no deviation, no bending. So this is second ray. If you want to take another ray, because there are thousands of rays, so the other one you can take from here, from the, let me call focal point. This is my focal point, and I can take another ray from the focal point like this. Please use the ruler, okay? This is the focal point. The ray I'm taking from the focal point. If the incident ray is passing through the focal point, so after refraction, what happens is it is parallel to the principal axis like this. This is a refracted ray after passing through the focal point. This one. So what happened? I take the rays from here and passing through the focal point. after a refraction, or you can say after passing through the lens, it is parallel to the principal axis. This is a principal axis, and this ray is parallel to the principal axis. Now where is the image? This point is the image of this point. So you can draw like this. This is the image. This is the image. You can write down I prime. So in this case, image, light is coming from this side, image is from on the other side. Light is coming from this side. We cannot say here behind the convex lens. So because both it is a transparent medium, because light can come from this side or light can come from this side. So here light is coming from this side, left side, and the image is from on the right side. I can say other side of the lens. Okay, so the image is inverted image. The image is inverted, and if you have an inverted image, this is a real image. Look, the real line, real rays they meet here. So this image is real image. You know that the real image, you can film that, or if you keep the white screen there, you can see the image there, or simply the real image can be obtained on the screen. So this image is real image, but it is inverted. Upside down. Okay, upside down. And you know, the image it forms on the other side of the lens, and you can also calculate the magnification here. The magnification is simply, if this is, let me call this is HO, object height, and this is HI, image height. Okay, so the magnification is you can use M, magnification M. This is equal to size of the image, that is HI, or you can say height of the image, divided by HO. This is the definition. Height of the image divided by height of the object, or simply you can say size of the image divided by size of the object. And this magnification M, this is also equal to, you can write down this of I, negative this of I divided by this of O. This is how you define the magnification. So what is this of I and what is this of O? This of I is, you measure the distance from here, from the center. So this is up to here. This is your this of I, image distance. This of I is image distance. And this one, from here to there, this is your this of O. This of O is the object distance. Please don't forget. HI, height of an image. Okay. HO, this is height of an object. This of I, this is simply image distance. And this of O, this is object distance. Okay, and in this case, you know, the image here is, this image is bigger than the object. Okay, bigger than the object. So I keep the object little bit in front of the focal point. Okay, so what happens if you keep the object at the focal point? What happens in that case? So if you draw again, this is your convex lens. Okay, draw the this is your principal axis. Here is the focal point. Here is another focal point. If you keep the object here, what happens then in this case? If you keep the object here, what happens? The idea is always same. You draw the ray parallel to the principal axis, and this rays, it goes like this. So I told you that in my previous lecture, if you want to draw the ray diagram, and if you want to locate the position of an image, you need at least two rays. So one ray you take from here and parallel to the principal axis. After passing through the lens, it passes through the focal point on the other side of the lens. Then another ray you can take like this from the center of the lens, this way. It is the center of the lens, so it goes like this. Make this ray is okay. Look at this ray. These two refracted rays, they are parallel. Where do they meet? Because I told you that to form image, two rays must intersect. But look, they are parallel. So we consider here these two rays, they meet at infinity. So your image is at infinity here then. Your image is at infinity. But the image is big. In this case, image is big. Image is real because it is upside down inverted image. So the magnification is more than 1 here. So this is the case if you keep the object right here at the focal point. Now I want to give you the one homework. You can try. You can use your ruler and protractor to draw this again. This is your convex lens, and here is the principal axis. This is your focal point F prime, another focal point F here. If you keep the object right here, let us suppose this is O prime, this is the object. Please complete this diagram. Okay, one ray you can take from here parallel to the principal axis, another ray you can take from there. Then what happened? Please do this. Okay, please do this. Okay, so this is the ray diagram. You can the convex lens is little bit important, more important than the concave lens. Okay, and here in case of lens we can use we call thin lens formula. Do you remember I gave you the mirror formula? The mirror formula that relates the focal length of the mirror, object distance, and the image distance. So the mirror formula is this: 1 over F equal to 1 over d sub O plus 1 over d sub I. This is the mirror formula. F is the focal length of the mirror, d sub O is the object distance, and d sub I is the image distance. Here also we can do the same thing. First let us do it for convex lens. This is the convex lens. This is the center line. This is the center line. Here you have the principal axis. Okay, this is your principal axis. Now you have to show the focal point. Okay, so where is the focal point? You have two focal point. You can call this is your focal point F, and here you have another one. This is your center. Okay, so another focal point is, you can call F prime, and let us suppose this is your object O prime. Now please complete the ray diagram. Can you do the ray diagram here? Complete the ray diagram. Okay, so the ray diagram is this ray. This is, draw the straight line, okay, because light always propagates in a straight line. This ray is parallel to the principal axis. So after passing through the lens, it passes through the focal point like this. Okay, and another ray you can take from the center of the lens. Let me call this is A right there. This is B. AB is equal to O prime here. Okay, so AB, this is equal to O prime. You need this. Okay. Now another way, I can take from the center of the lens like this. Okay. So draw the solid line this way. Okay. So you have an image right there. This is the image. Let me call I prime. Okay. So don't forget to keep the pointer like this arrow. So O prime, AB, they are equal, and here you have the image I prime. Now the thin lens formula is also 1 over f equal to 1 over d of O plus 1 over d of I, and this is for the convex lens. For the convex lens, you can write down 1 over f equal to 1 over d of O plus 1 over d of I. Okay, so can we prove that? Look at this. This triangle, and this triangle, they are similar because this is 90 degree, this is 90 degree, so they are equal. These two angles are equal. This angle is equal to this angle because they are vertically opposite angles. Then of course the remaining angle here, this angle must be equal to this angle. So triangle ABF and triangle I prime F, they are similar. This triangle, you see the highlighted triangle, those two triangles, they are similar. If they are similar, I can write down AB divided by I prime. You can do this. AB divided by I prime. This is equal to what next? You can write down AF divided by IF. So here I write down AB. AB is the object. So it is better, let me first write down the other way. It is better to write down I prime because it is image AB. This way. This I prime, this equal, divide by this AB. Because this angle opposite to this angle is I prime. Opposite to this angle is AB. So I prime divided by AB, this equal to, you can write down IF divided by AF. Okay, what is I prime? This is your, you can write down HI, height of the image, and this is HO, height of the object. So you can write down like AB equal to OO prime. That is why you can do this. I prime divided by, this is also equal to OO prime. This is equal to IF divided by AF. Okay. So what is II? This is HI, and this is HO. This is equal to IF. What is IF? Look here. IF. This is IA minus AF, right? So IF is AI or IA minus AF, divide this by AF, right? HI divided by HO equal to AI minus AF divided by AF. What is AF? This is focal length. AF is the focal length, and AI, this is your image distance. Okay, so this is, you can write down from here, HI divided by HO, this is equal to AI. AI is the image distance, so you can write down d of I minus AF. AF, look, this is the focal length. F, di minus F, divide this by AF again, so it is F. We are not done yet. Now think about the other triangle. Can we think about, let's see, we need two similar triangle again. So can you figure out two similar triangle, another pair of similar triangle? Another pair of similar triangle. Look at this. This one. This triangle and this one. Are they similar? Look at this. This angle is 90 degree, then of course this angle is 90 degree. This angle here is equal to this angle because they are vertically opposite angle, then of course the third angle they are equal because the remaining angle they must be equal. So triangle O prime A, this triangle O prime A and A, you can say like I prime A. I prime A are similar. This, you see the blue highlighted. O prime A and I prime O, they are also similar triangle, are similar triangle. Then if they are similar triangle, you can write down HI over HO. You can write down like this, I prime divided by O prime. This is equal to AI, this AI divide this by AO. AI divided by AO. Okay, so I prime, that is HI. O prime, that is HO. And AI is the image distance. This AI is the image distance. And AO is the object distance. This is this of O then. So HI divided by HO is equal to DI divided by this of O. And here also you have HI divided by HO equal to DI minus F divided by F. So you can equate them. Look, HI over HO. Over there you have DI minus F over, it's the same thing. Look, HI over HO. Here also you have HI over HO. So if you equate these two equations, you can call this is equation 1, this is equation 2. If you equate these, if you compare these two equations, you can write down that DI minus F divided by F, this is equal to DI divided by this of O. Okay, so if you simplify this, this is DI divided by F minus 1, this is equal to DI divided by this of O. Okay, from here you can simplify that. Okay, DI divided by F, this is equal to this negative one, bring on this side, it is 1 plus DI over this of O. So if you divide by this of I on both sides, divide this of I on both sides, what happens? If you divide by like this, 1 over DI here, and you do this, 1 over DI there. If you do this, you will get 1 over F equal to 1 over this of I plus this of I cancel out, so you will get 1 over this of O. Therefore, you can write down 1 over F, this is equal to 1 over this of O plus 1 over this of I. Okay, this is the thin lens formula for convex lens. 1 over F equal to 1 over object distance plus 1 over image distance. And this is for the convex lens. For the concave lens also, you can write down in the same way. I don't derive the formula. For convex lens, you have 1 over F equal to 1 over this of O plus 1 over this of I. I told you that the focal length of the convex lens is positive and the focal length of the concave lens is negative. Okay, so for the concave lens, for concave length, you can write down 1 over f, but the focal length of the concave lens is negative, so you have to put negative here. Negative 1 over f equal to 1 over d sub o. Okay, look, this is the image distance. The image formed by concave lens is virtual image, and the image distance for the virtual image is negative. That is our sign convention. If you have the real image, the image distance is positive. If you have a real image, the image distance is positive. Convex lens makes a real image. That is why you have a positive image distance. Concave lens makes the virtual image. That is why the image distance is negative. So you have to write down minus here, 1 over d sub I. This is for the concave lens. So the only thing you have to keep in mind is, for the lens, you can write down 1 over f equal to 1 over d sub o plus 1 over d sub I, but you have to apply the sign convention. What are the sign convention then? Sign convention. Okay, number 1, the focal length of convex lens is positive, and that of concave lens is negative. Okay. Number 2, the image distance of virtual image. If you have a virtual image, you can write down the virtual image. If you have a virtual image distance is negative. Image distance is negative. If you have the real image, the image distance is positive then. Image distance is positive. And another sign convention is, if you have the upright image, the image height is, if it is upright, image height is positive, okay? If you have an upright image, it is positive, and if you have the upside down, it is negative, relative to the object height. Object height we always take a positive. So if you have an upright image, it is positive, image height. And if you have an upside down, inverted, it is negative, relative to the object height. And we take the object height always positive. Okay, so this is the sign convention. Look at this. The focal length of the convex lens positive, focal length of the concave lens negative, and if you have a real image, the image distance is positive. If you have the virtual image, your image distance is negative. And if your image is upright, image height is positive. If your image is upside down, we call that inverted image. In that case, it is negative relative to the object height. Object height we take positive always. Okay, so this is the sign convention. And of course, to apply this formula 1 over f equal to 1 over d sub o plus 1 over d sub I, you need to know the sign convention. I already applied that here, because this negative sign is because concave lens, the focal length is negative, and this negative sign, the concave lens produces the virtual image. That is why the image distance is negative, and I put the negative sign there. Okay, so this is the thin lens formula. Okay, so here we call the focal length of the lens, and if you measure like 1 over f, reciprocal of the focal length, anybody know what is that? The reciprocal of the focal length. The reciprocal of the focal length we call the power of, this is the power of the lens, power of lens, okay, 1 over f, okay, and the power of length, the unit is, look, 1 over f, it is simply 1 over meter, or simply you can write down per meter, but this is called as the diameter, d, diameter. So the power of the unit of power of length, P, this is 1 over, this is the power 1 over f, focal length, this is focal length, this is the power, and the unit is, you can write down per meter, or you can also call diameter. Okay, so this is diameter, or simply you can use d. And the focal length of the convex lens is, positive. So the power of the convex lens is positive, and the diverging lens, that is concave lens, the focal length is negative. So simply the power of the concave lens is negative power. If you wear the glass, sometimes you have it depends on your what types of error you have. Okay, what types of defect you have. Depending on the defect, you have the positive power or negative power, concave lens or convex lens. Okay, so the diameter, that is the unit of power of the lens, unit of the power of the lens. Okay. Now, using this formula, I gave you I drew the one ray diagram when the object is at infinity. Like, look at this. This is the lens, convex lens, and if you keep the object at infinity, can you figure out the image distance using the formula? Using the formula, use the image distance. Look at this. These are the ray coming from the infinity, object at infinity. Our formula is 1 over f equal to 1 over d sub o plus 1 over d sub I. Object is at infinity, so object distance is infinity. So 1 over f equal to 1 over infinity plus 1 over d sub I. Okay, what is 1 over infinity? It is 0. So you can write down 0 plus 1 over d sub I. So in this case, what is d sub I then? Look here, you can write down 1 over f equal to 1 over d sub I. So what is d sub I? D sub I, this is equal to f. That means your image distance is focal length. So this length, this is your image distance. That is why it goes like this. So in this way also you can figure out the image distance. This is the case if the object is at infinity. Now the second case is if you keep the object at the focal point, what happens then? If you keep the object at focal point, look at this. If you keep the object here, focal point, so this is O prime, this is object, so this length is focal length, but this is also object distance. Object distance is equal to focal point. So, object distance is equal to focal length. Okay. Now use this equation, 1 over f equal to 1 over d sub O plus 1 over d sub I. Okay, 1 over f equal to 1 over d sub O is equal to focal length plus 1 over d sub I. 1 over d sub I. Now 1 over f minus 1 over f equal to 1 over d sub I. This is 0 equal to 1 over d sub I. So what is d sub I? So d sub I is equal to infinity then. So image form at infinity. That is why, look, this is the way of drawing. Another way you can take from the center like this, and look at this, they are parallel. Okay, they are parallel, so the image form at infinity here then. That is why your image distance is infinity. Okay, so you can draw the ray diagram easily. Even if you need a help of this equation, you can use that. At any position you can draw the ray diagram. You can draw the ray diagram. Okay, similar to this, if you want to draw the like concave lens diagram, like a ray diagram on concave lens. Okay, this is your concave lens. This is the principal axis. There is a like a focal point F, and there is another focal point F prime. So if you keep the object here, can you think about it? This is O prime. How do you draw the ray diagram then? Can you draw the ray diagram? How to draw the ray diagram? You don't have that many positions in case of concave concave lens. So one you can do like this. So how do you complete? It goes, this is a focal point, so refer to this focal point. Don't draw the solid line here, then it goes like this. Another one, if you take from the center, it goes in a straight line there. If you take from the center like this way. So another ray, if you take from this, look at this, from this point, please look here, if you take from like from there, so what happens is, if you take from the focal point, it must go parallel to the principal axis, because I told you, if you take the rays from the focal point, then it must be parallel after. So if you take from this focal point, it goes parallel. So if you extend this line, they meet right here. Look, these three rays, they meet at this point. So this is this one. This is the image I prime. So image formed here. Okay, so this is the case of concave lens. So this one, the third ray, if you take from this focal point, after refraction, the rays you take from the focal point, that must be parallel to the principal axis. That's why it is parallel. Okay, think about this carefully. If you are confused, you can take this ray and you can take another one from the center. Two rays are enough to produce the image. Okay, so this is the concave lens ray diagram, and here I want to give you another formula we call the lens maker's formula. Sometimes this formula is useful. Lens maker formula. The lens maker formula is a relationship between n, what is n? Index of refraction. We talk about this in refraction. Index of refraction. So the lens is made of glass, you know that. So n is the index of refraction of the lens, the glass. What is f? Focal length. I don't think you need this. Focal length. R1 and R2. Radii of curvature. So the relationship between the radii of curvature, you have two radii of curvature, R1 and R2. R1 and R2, they are radii of curvature of the lens. F is the focal length and n is the index of refraction, or you can call a refractive index. And the lens maker formula is 1 over F. This is equal to n minus 1 times 1 over R1, radius of curvature of the first surface, plus 1 over R2, radius of curvature of the second surface. This is the lens maker's formula. This is 1, okay? 1 divided by R1 plus 1 divided by R2, and you have n minus 1 here. This is the lens maker's formula. So the lens maker's formula is nothing but it is the relationship between index of refraction of the glass, because the lens made of glass, focal length of the given lens, and the radii of curvature R1 and R2. So this formula is useful. This formula is useful. Okay, so that's all. So we finished the one chapter, like we did reflection of light, refraction of light, critical angle, total internal reflection, and lenses: concave lens, convex lens, concave lens, diverging lens, convex lens, converging lens, and of course we did the lens maker's formula. This is the lens maker's formula, and we did thin lens formula also. 1 over f equal to 1 over d sub o plus 1 over d sub I. So this chapter is done. Then I will start another chapter in my next lecture. Okay, thank you.